There are just a few homework questions I wanted to go over because in the past years, there's been the same type of questions that keep coming up from students. So even though you have the solutions in the back of the textbook and you have the solutions manual that goes step by step through these questions, I just want to take a few minutes and put a video together to go through specific ones to kind of help, deal with any questions that you might be having while you're going through the questions. So the first one we're going to look at is from lesson 5.2, question 9. And that was when we were looking at special angles. So we want to show that tan 30 plus 1 over tan 30 is in fact equal to 1 over sine 30 cos 30. So we want to use our exact values for this. So if we want, we can kind of break this down into left side and right side. So left side, I have tan 30 plus 1 over tan 30. And then of course on the right side, 1 all over sine 30 cos 30. So I'm going to put in my my exact values for the special angles. So tan 30, if you remember, is root 3 over 3 plus 1 over root 3 over 3. On my right side, I have 1 all over sine 30, which is a half, times cos 30, which is root 3 over 2. Now I'll stick with the right side here. I'll multiply those two together in my denominator. So 1 times root 3 and then 2 times 2 gives me root 3 over 4. And then because I'm dividing by a fraction, remember we flip and multiply, so it becomes 1 times the reciprocal of this, which ends up being 4 over root 3. If I go back to the left side now, I'm going to use that same principle here. I need to flip this fraction on the bottom because it's 1 divided by root 3 over 3. So I'm going to take the reciprocal. So I have root 3 over 3 plus 3 over root 3. Now in this case, I need to get a common denominator, so I can add them together. So I'm multiplying this fraction, numerator and denominator, by root 3. This fraction, numerator and denominator, by 3, right? I'm multiplying by whatever the opposite denominator is. So I'm going to do root 3 times root 3, which is root 9. Square root 9 is 3. And this becomes 3 root 3. Plus, I'm multiplying this by 3. So I get 9 over. Multiply that by 3. We get 3 root 3. Now I can add them together. 9 plus 3, of course, is 12 over 3 root 3. Now we notice that this can simplify. I have a 12 on top of the 3 on the bottom. There's no addition or subtraction here, which means I can simplify. 3 divides into 12 4 times, and I'm left with 4 over root 3. Now I know that I said we shouldn't leave a radical in the denominator because it's not good form. But essentially what we're looking for here is just getting left side to equal right side and showing they equal each other. So we've proved that that's the case. Moving on to question 4 from lesson 5.4. Nobody has problems with questions A and B, but when we get to C and D, that's when we start having some questions. So use a related acute angle to state an equivalent expression. So let's draw our 4 quadrants. So we'll take a look at C first. And if I draw the 4 quadrants, 110, of course, is here. So that would be my kind of terminal arm. And that is 110 degrees. That's clearly the principal angle, because it's greater than 90. Which means that my acute angle in here has to be 70. Now, if you put the tan of 110 into your calculator, we're going to end up with a negative decimal. Because, according to the CAST rule, tan is negative in quadrant 2. Tan is also negative over here in quadrant 4. So if I put my other terminal arm over here in quadrant 4. My acute angle will still be 70. That means that that principal angle is going to be 360 subtract 70. 360 subtract 70 is 290. So the tan of 290. Now just to check, we have the tan of 110, negative 2.7474. Now we type in the tan of 290, and we get the exact same decimal. That's how we know that the angles are the same. So an equivalent expression to tan 110 is tan 290, because you get the same decimal. We'll use that same process for D, except now we're looking at the sine of 350. So draw our 4 quadrants. 350 is, of course, right here, almost to 360. So we know that this angle in here is going to be 10 degrees, because that's 350. And now again, if we look at the cast rule, sine is negative in this quadrant. So without even using a calculator, we know that the sine of 350 is going to be negative. The other quadrant where sine is negative is over here. So I can put my other terminal arm in this situation, and again, that's 10 degrees. So to go from the initial arm, which is the positive x, over here to my terminal arm, that's going to be 180 plus 10, so that's 190. So we're looking at the sine of 190 degrees. And again, if we type it in, sine of 350, whoops, negative 0.1736, sine of 190, the exact same decimal. So that's how we can check. Sine of 190 is equivalent to the sine of 350. We get the exact same decimal. So that's kind of what we're looking at with question 4. The next one I wanted to look at is question 6, again, from 5.4. The question does tell us that we're in quadrant 2. So that's good. So we have a variety of them here. I'm going to look at E, tan of negative 1.1. So again, it's asking for the exact values of x, y, and r. So I need to change my decimal here into a fraction. Now, negative 1.1 is the same as negative 1 and 1/10, right? Because the 0.1 is 1/10. And I change that into a mixed fraction. 10 times 1 is 10 plus 1 is 11. So I end up with the tan of negative 11/10, right? If we do 11 divided by 10, we get 1.1. So tan theta is equal to 11 over 10. If you can see that. Tan, we know, is equal to y over x. So one of those two is going to be negative. We know that we're in quadrant 2. So if we're here in quadrant 2 with our triangle, we know that x is the one that's going to be negative and y is going to be positive. So x is negative 10, y is positive 11. And now we want to find r. So x squared plus y squared equals r squared. So that's 100, and that's 121. So it should be 221. 10 squared plus 11 squared, 221. So r is equal to the root of 221. And again, the r is always positive. So for part 1, x is negative 10, y is 11, and r is root 221. Sketch theta in standard position. So of course this is our principal angle that we're going to find. And we'll use beta to represent my acute angle. So because sine is positive in this quadrant, I'm going to stick with sine. So sine of beta is equal to y over r, 11 over root 221. So beta is equal to the sine inverse of 11 divided by root 221. And on our calculator, we get bracket 11 divided by root 221, 47.7. So around that to 48 degrees. So the acute angle is 48. Last step to determine the principal angle. 180 subtract 48. 132. Okay, and that's how you do those questions. They're all basically done the same way. And for all of them, of course, remember you are in quadrant 2. Moving on. Question 9, very similar to question 8 in the homework as well. So 8 and 9, same type of question. We want 2 possible values of theta. All that means that we're looking for both principal angles. So let's go with, let's try D. All these are done the same way. So if we look at D, cos theta is equal to negative 0.2882. First thing we recognize is that cos is negative. That tells us the quadrants that we're in. So based on the CAST rule, C-A-S-T, cos is negative in quadrant 2 and again in quadrant 3. Our first step is to determine that angle. So we're going to do the cos inverse of this. So cos inverse of negative 0.2882. And when we do that, what we'll notice is that it actually gives us the principal angle rather than the acute angle. And cos does that when it's negative. So we just recognize, because it's greater than 90, 107 is the principal angle. So once we're at the principal angle, then we know what the acute angle must be. So that's 73, which means that this acute angle is 73 as well. So we determine the other principal angle, 180 plus 73. 180 plus 73, 253. And if you want to check to make sure you got the right answer, just type in the cos of 253. And we get pretty close to the same thing. The reason why it's not exact is, of course, we rounded our angles, right? So because we round, again, you see how the decimal is off, but pretty close. Let's also look at let's do B. I'm going to go backwards here. And we'll look at tan as negative 0.7571. So again, we draw our 4 quadrants, and we draw our terminal arms in the 2 quadrants where tan is negative. C-A-S-T. Tan is negative in those 2. I find my angle. So tan inverse negative 0.7571. Now it says negative 37 degrees. Remember, that just means the direction. So my acute angle is going to be 37 because I'm going 37 degrees kind of clockwise. So the acute angle will be the same there as well. So the acute angle is 37. I want to find the two principal angles. So this would be the first one, and this would be the second. So the first one, 180 minus 37. So 143. And then the other one would be 360 minus 37. And that would be 323. So if we type the tan of 143, again, not exact because we rounded. And if we do the tan of 323, we get the same thing. So that's how you can tell. I mean, they're not exact, but they're pretty close. So you can tell if you're right or not. Another question to look at is question 12. Given cos is negative 5 over 12, which quadrant are we in? Primary trig ratios and all possible values of theta. Well, the first thing we have to remember is that cos is equal to x over r. So if we have negative 5 over 12, we know the x has to be negative 5 because the r always has to be positive. So when we draw our quadrants, we know that our triangles have to be on this side because x is negative. This has to be negative 5. R is 12. So for part A, in which quadrant could the terminal arm of theta lie? It could lie in quadrant 2 or in quadrant 3 because those are the two quadrants where x is negative. Determine all primary trig ratios for theta. So we're looking for sine, cos, and tan. We have to figure out what y is. So x squared plus y squared equals r squared. X we know is negative 5 plus y squared equals 12 squared. So y squared is going to be 144, subtract 25. 144 minus 25 is 119. And of course, we have to take the square root of that. So what we end up with is positive root 119 up top and negative root 119 in quadrant 3. So you have positive and negative. And then with that, from your acute angles, you can determine sine, cos, and tan. Now, I can use either one of these to determine that acute angle. It doesn't matter. Let's use sine up top here. So sine, I'll use beta for my acute angle, equals y, root 119, over r, which is 12. So I'm going to do the sine inverse of root 119 over 12. So sine inverse root 119 divided by 12. 65 degrees. So my acute angle here and here is going to be 65. I can get my two principal angles. My first one, 180 minus 65, 115. And the second will be 180 plus 65. $245. For trig identities, lesson 5.5, I know that they show step-by-step solutions, and then you can look off of that, but there were a couple I just wanted to offer an explanation on how we get them. So the first one was B, that we'll look at. So for 7B, I'm going to FOIL those two brackets first. So cos theta, 1 times cos theta, minus 1, plus secant theta cos theta, multiplying them, so I stick them together, and then minus secant theta. Cos theta minus 1 plus secant, I'm going to change to 1 over cos. And by doing that, secant is 1 over cos. I'm multiplying that with cos. So the cos on the bottom cancels out the cos on top. And I'm just left with the plus 1. So negative 1 plus 1 is 0. So now that's gone as well. So I have cos theta minus secant theta. I'm going to multiply this cos into the bracket. So I get cos squared theta minus secant theta cos theta. Change that to 1 over cos. Now, if I wanted to, I could have changed secant to 1 over cos back here in this step. Doesn't matter. So now I have 1 over cos times cos. Again, those cancel out. And I'm left with cos squared theta minus 1. Now, if you remember in the note, the Pythagorean identity, sine squared plus cos squared is equal to 1. If I rearrange that, I get sine squared equal to 1 minus cos squared, right? If I rearrange my Pythagorean identity. The problem is that these are not the same, right? Cos squared minus 1 and 1 minus cos squared are not the same. Very similar, but not the same because the signs are opposite. So because the signs are opposite, 1 minus cos squared is equal to sine. So cos squared minus 1 is equal to negative sine squared theta. And that's why in your textbook it has an answer of negative sine squared, because the signs are opposite to this from what they should be. Okay? For C, you would just FOIL those two brackets together. Right? You want to multiply those, then you can add in the 2 cos squared x. And it'll simplify. For D, this is actually a factoring question in the numerator. Because if we get rid of that cosecant squared, if I change that to x squared minus 3x plus 2, now it becomes more recognizable as a factoring question. More importantly, a sum and product. Two numbers that add to negative 3 and multiply to 2 are negative 2 and negative 1. So x minus 2 and x minus 1. And then you can use that to kind of simplify 7C further. And for question 8, just two identities I wanted to look at. The first one is 8B. And the other one will be F. So for B, I'm going to start with the left side. More complicated. Tan squared, I can change that into sine squared. Now first off, they have different symbols here. You can just treat it as theta. It doesn't matter. So we can use, we're more familiar, we're comfortable with that. Sine squared over cos squared. And all of that over 1 plus tan squared. Now the reason why I'm going through this one is just to refresh your memory, So I didn't really talk about that in the lesson, but back here for Pythagorean identities, we have 1 plus tan squared. So 1 plus tan squared is in fact equal to secant squared. And that's where that comes from. Secant squared theta. And secant squared is equal to 1 over cos. So sine squared over cos squared all over 1 over cos squared. I changed secant squared into 1 over cos squared. Now fraction divided by a fraction, I'm going to flip and multiply. So sine squared over cos squared times the reciprocal of this, which is cos squared over 1. The cos squares can cancel, and I'm just left with sine squared. So therefore, whoops, we can say left side equals right side. And then finally for f, again, I'm going to stick with the left side. And tan theta plus 1 over tan theta. Well, 1 over tan theta, I'm going to make life easier. I'm going to get rid of this fraction. So 1 over tan is cotan, right? This is just a reciprocal. So I can change this to tan theta plus cotangent theta. Now I'm not dealing with a fraction. Get everything in terms of sine and cos. So sine theta over cos theta plus cos theta over sine theta. And I had mentioned this before in the note when I was going through the lesson, is that you want to get a common denominator. So I'm going to multiply this top and bottom by cos and this top and bottom by sine. So then I get sine squared plus cos squared all over. I'll combine the two denominators together. Sine theta cos theta. And sine squared plus cos squared is the Pythagorean identity. So that equals 1. So we have 1 over sine theta cos theta. And left side equals right side. And one thing that I should mention as well, specifically with identities, is that there's more than one way to go about it. So just because you do your steps a different way than what's shown in the textbook, it doesn't mean that it's wrong. Just there's multiple ways of going about it. So as long as it's, of course, mathematically sound and you're using the proper identities, then there's different ways you can go about it. So hopefully that helped with some of the homework questions. Sometimes an explanation helps along with looking at the actual steps in the textbook. So hopefully that provides some clarity.